Hi everybody, I'm Hannah Faye. Welcome to my channel. Today we're going to talk about object-oriented programming. First of all, what is it? Object-oriented programming is a style of programming. It revolves around classes and objects are instances of classes. And don't worry, I'll show you examples. Object-oriented programming follows a few main principles, and I'm going to dive into those principles in this video. The first principle is encapsulation, or the hiding of implementation details. Encapsulation is really nice because it hides data from parties that you don't want to access it. My compiler is being a little weird, so I am using this online compiler on onlinegbd.com. So if you ever need a compiler, this one is free and it does a ton of languages. So anyway, I want to focus on encapsulation right here. As you can see in the class flower, I have this declared a private string called flower name. Now, encapsulating data basically makes it unavailable outside of that class, and it can only be accessed by a member function within that class. This is basically what it looks like. You wrap it inside of a class. Think of it as wrapping the data all together in a package. In order to get that data, you have to have the entire package. Okay, so that previous example was Java. Now I'm going to show you one in C++. The next principles I'm going to talk about are construction and destruction. Construction is creating an object using a constructor, and destruction is destroying an object using a destructor. Depending on your compiler, it's not always necessary to define a destructor. A lot of times your destructor will provide a default destructor. Or depending on your language, if you're using Java, for example, it has built-in garbage collection, and so you don't have to worry about destructing objects when you're writing your code. That's why I'm not going to show you that example in Java. I can actually define a destructor here. So this is defining the constructor for what's called rational number. Okay, that's my function rational number. And it takes two integers. So this is creating their constructor, and the destructor is the exact same thing, but you put the tilde in front of it. So I included this little message to be printed out when the object is constructed, and this little message to be printed out when the object is destructed. I am going to write out So this is what happens. It gets constructed and then destructed. Our next principle is inheritance. And now we're going back to our Java example because I wrote this example for this specific reason. So, okay. Inheritance allows a class to be defined as a modified version of another class. We have base classes and subclasses. So let's say we have class A. That's our base class, and then class B inherits from class A, then class B becomes class A's subclass. Sometimes they're called parent classes and child classes. They have multiple names. It's kind of just preference. So we have our class flower. All right, this is the one I discussed, encapsulation. So it has all these, it's got this string flower name. It has a setter method. And then it has this color method. Okay, so this is our base class. All right, and then I wrote two subclasses for flower. Roses is our first subclass, and violets is our second subclass, okay? So as you can see in Java, in order to inherit from a class, you just have to write extends and then the parent class name. So I have class roses extends flower. And same with violets, extends flower. So it will inherit every attribute that flower has, and then you can also add your own. When you want to change the attributes of an inherited class, that is called polymorphism. In order to explain that, let's go back up to look at what exactly flower consists of. we have two methods. Set name, which will give us this output of the flower name, which is inputted, and then it'll say is the name of the flowers. And then we have this method called color, which will print a line saying you will receive a white bouquet. Polymorphism selects which method should be ran based on the class of the object. So even though flower has a method called color, and it takes no arguments, and all it does is print this out. In the class roses, we decided to switch it up a little bit. So we are using the method color. However, we're now taking an argument, a string called fragrance, and that will be inputted by the user. And then instead of outputting you will receive a white bouquet, you will receive a, and then it will say whatever fragrance you put in, red rose bouquet. So even though you might call the method color, depending on what class you are calling it from, it will have a very different result due to polymorphism. Okay, I hope that was a clear example. I'm gonna explain a little bit more with my violets class, okay? I also decided to switch up the method color because I wanted to show you guys how you can really change the exact same method and call it, but it's gonna give you a very different output. So in this one, we're taking an integer, and that integer is quantity, and then it's going to print out a message that says you will receive whatever quantity you entered flowers in your violet bouquet. Very different outputs depending on how you call this method. And now I'm going to show you. So up here I have called 3 constructors, one object for each different class that I have. So object 1 is from our flower class. We don't need to put an argument in. 2, that one was a string of fragrance, so we'll put sweet. And 3 was a integer. Oops. Okay, let's run it. We called the same method, color, but on 3 different objects from 3 different classes. So we got 3 completely different outputs. Those are the main principles of object-oriented programming. So hopefully this video was informative. If you liked it, please give me a like. Remember to subscribe, and I will see you next time. Bye!